This video will explain the details of how to generate an artificial material using PuMA. There are 4 different options for artificial material generation. The first is carbon fiber preform, which creates a collection of randomly oriented intersecting cylinders, which attempts to mimic some of the microscale characteristics of a carbon fiber preform. The other 3 are sphere, box, and cylinder, which are all ideal geometries used mostly for verification. So we'll start with sphere. You put in the range in x, y, and z, followed by the radius and the voxel length, and click generate. When generate is clicked, the material is created, and the surface area in specific surface area, raw surface area, the number of triangles used for the visualization, and the porosity are displayed. The visualization is also created and shown here. As you can see, with a radius of 40, it creates a very good representation of a sphere. If the radius becomes very small, say 2, the representation begins to lose accuracy, obviously, just because of the discretization size. There's also an option to create a hollow chamber within the sphere. So if, for example, we created a lumen of radius 5 within the sphere of radius 40, we can see that as we zoom in. So we're now visualizing inside the material, and you can see that there's a second sphere inside, which represents the hollow chamber within. For box, it's the same process. You input the domain range in x, y, and z. You then input the length in x, y, and z, as well as the start. So this will create a box of length 50 cubed inside a domain of 100 cubed that will be centered because x, y, and z all start at 25. And you can see there it is. The cube does not have to be square. It doesn't have to be cube in shape. It can be any kind of rectangular shape. You can have this with a value of 100 instead. Finally, the cylinder, very similar to the sphere. You input the range in x, y, and z, as well as the cylinder height, the cylinder radius, and then the voxel length. And you can also create a hollow cylinder. Now, finally, for the carbon fiber preform, it's a little bit more complicated, but it's still relatively straightforward. You have the input parameters of the domain range in x, y, and z. So we'll just make 200 by 200 by 400. The average radius of the cylinder, so we'll say the average radius of 10. Radius variation, we'll say variation of 1. Average length of 200. Length variation of 100. Angle variation. So what this means in the x and y planes, the cylinders are going to be oriented completely randomly. However, in the z plane, you can choose the angle variation plus or minus a certain amount. So this tends to mimic the characteristics of a carbon fiber preform, where the fibers are oriented such that it's more flat in the z plane. This is done so that the thermal properties are less conductive in the z direction. So in this case, we'll put an angle variation of 20. Finally, you put a voxel length, typically 1, and then you select a porosity, we'll say 0.85. Now, when you generate, it's, as you can see in the console, it's outputting the number of spheres that it's creating, and now you can see the material that is generated. Obviously, this is a very small example with relatively large cylinders, so if you want it to mimic the characteristics a little bit closer, you can change the radius size to, say, 6 and put a porosity of 0.8. And you can see that it begins to take on the form similar to that of a carbon fiber preform, in this case a relatively dense carbon fiber preform. So that sums up the artificial geometry. If you want to create a visualization, just click on Create 3D Visualization. It'll create a new window. And that concludes this section.